Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 39 of JEE Advanced Physics Paper 2, 2014. Students, let us solve the next question. 39. A block of mass M1. This is block of mass M1, which is 1 kilogram. And another block of mass M2, 2 kilogram here, are placed together on an inclined plane with an angle of inclination theta. This is the angle of inclination theta. Various values of theta are given in list 1. So these are the theta we vary, sometimes 5, 10, 15, 20, something like that. The coefficient of friction between the block M1 and the plane is always 0. Coefficient of friction between the block M1 and the plane is 0. So this one is 0. I can see here there is no friction between this block and the plane. And the coefficient of static and dynamic friction, that is coefficient of static friction and kinetic friction between the block M2 and the plane are equal to 0.3. So this block and this one is having coefficient of friction 0.3. In list 2, expressions for the friction on block M2 are given. What is given? Friction is given. This is the expression of friction. Friction that will act on this M2 block is given. This is the M2 block, and the friction that will act on this block is given. This is M2 block, because M1 is frictionless, so there is no friction, only friction will act on this M2 block. These are the given values. Match the correct expression for the friction in list 2 to match when this friction will act with the list 1. When theta is 5 degree, what friction will act on block M2? When theta is 10 degree, what friction will act on this block? And so on. The acceleration due to gravity is g. Useful information: tan 5.5 degree is 0.1, tan of 11.5 degree is 0.2, tan of 16.5 degree is 0.3. These are the informations given, and therefore we have to solve this. So we have to first understand that in case of an inclined plane system, if a block is kept here and the smaller block is kept here, then this is obviously M2 and this is M2 and this is M1. So first of all, write the general expression. If this angle is theta, then we know that this will have two components. M2G will have two components. One is along this direction, that is M2G sine theta, and this component will be M2G cos theta. This is theta, this will be theta. Similarly, for this block as well, we'll have in this direction, that is M1G cos theta. In this direction we have M1G sine of theta. And if I want to write about the normal reaction, then normal reaction will be in this direction for this block, and in this direction for this block. This is normal reaction N1 and this is normal reaction N2. Now this surface is frictionless, this is having some friction, so this block and this has friction, and that is 0.3 is a value given. 0.3 coefficient of friction. Now we have to find what friction is there, and because this is frictionless, so no friction will act on this block, only this object will act on. Now what is the force, driving force? So first of all we have to find the driving force down the plane what force is responsible for the motion or impending motion of this block. Now in this direction, this block is this block is subjected to m2g sine theta. So this is the driving force for this block. For this smaller one, the driving force is m1g sine theta. So this is frictionless, so this force exactly acts on this one. So the total driving force on this block is m2g sine theta and m1g sine theta. So the friction that will act in this direction to prevent the motion, if we want that the blocks this block doesn't slip, the friction should be more than equal to these forces, driving forces, because if I consider this a block, suppose 10 Newton force is acting is a driving force, then to stop it, friction has to be 10, then only it will stop. So for no slipping, the friction force and this must be equal, or the driving force should be less than the maximum or limiting value of the friction. So I'll write for block M2 not to slip, for block M2 not to slip, what we have, that the driving force, that is M1 plus M2 G sine theta, because you can see this force and this force, this is a combination of these two forces which is driving this. These two forces are acting in that direction, so this block M2 is actually subjected to this force and this force, because this is frictionless. So this M1G sine theta as well as M2G sine theta both will act in this direction, and the sum of this is this. This should be less than equal to, it should be less than the limiting friction, and that means M1 plus M2 G sine theta must be less than equal to, what is that limiting force of friction, because we know that limiting force of friction is mu s into n. This is how we find that. Mu s is 0.3, and okay, I'll put that later on. Mu s into n, n is the normal reaction. Then you must remember that the normal reaction in this case will be of this n2 only, not n1 plus n2, because friction is acting on this block, so normal reaction of this block is considered. This is an important statement. So we have nothing to do with this n1, only this n2, because friction here is 0, so only n2 is considered. So if I consider n2, and that n2 is m2g, here is n2, and that is, you can see here, this n2 matches with m2g cos theta, because in this direction the displacement of this block is 0. So if I put that m2g cos of theta, then m1 plus m2g sine theta is this. If this condition is satisfied, the block will not move. If I solve this will cancel, g will cancel. M1 plus M2, I now substitute the value. M1 is 1 kilogram, so 1 plus 2, this is 2 kilogram. Sine theta is less than equal to 0.3, M2 is 2 into 2 cos of theta, or this 3 sine theta is less than equal to, this is 0.6 cos of theta, or tan theta is less than equal to 0.2. You can see this is divided here, 0.2. 0.2, tan theta less than equal to 0.2. So tan theta is less than equal to 0.2. We have already seen in the question 0.2 tan theta. So theta will be this one is given. So that means tan of 11.5 degree is less than equal to 0.2, because this is that, so theta should be less than equal to, so theta, so from here tan theta is this, that theta should be less than equal to 11.5 degree. So at best you can have equal to 11.5 or it is less than that. If theta, all theta less than suppose 11.5 degree, in that case the block M2 will not slip. This means what? Now we will see our options. What are the options given to us? You can see that the first case we'll consider the option P. We'll consider one by one all the options. First is P. The P statement says that theta is equal to 5 degree. Now in P, theta you have to consider 5 degree. This is the condition. So if that inclined plane is having angle 5 degree, theta is 5 degree, then what will happen? You can see that theta is less than 11.5 or 2 theta less than 11.5, there is no slipping, and this theta is 5 degree, which is obviously less than 11.5 degree. Since theta is 5 degree, which is less than 11.5 degree, so up to 11.5 degree it will not slip, so at 5 degree also it will not slip. So it will not slip. So the conclusion we are doing is that M2 does not slip. Then if it doesn't slip, then what prevents it from slipping? Friction. Then friction you have to find. What is the friction acting in this case? Now the friction is always equal to the, if it is not slipping, then it is equal to the applied external force. Frictional force will be equal to applied external force. You must remember one point, that as long as the body is in static equilibrium case or static friction case, that the body has a tendency to move but it is not moving. That means you are applying a force, but still it is not moving. That means that force is counterbalanced by the frictional forces. The limiting friction you should not put, because the limiting friction may be more than the applied external forces, because the aim of the friction is to keep the two surfaces in contact. There should not be any relative motion. So the applied external force is counterbalanced by the frictional forces if it has the its ability is within that limiting friction. So the external force that is responsible, in the diagram I showed you that this is shown here, the net external force acting in general case is this plus this sine theta. So this is the net external force. That means in this situation, if I only draw this block M2, which is experiencing the force that I have drawn there, that is M1 plus M2 G and sine theta, then if it is not slipping, it doesn't slip, so the friction in that direction, the friction that it will act on this is obviously equal to this value. Under this condition only it will not slip. So the friction must be equal to M1 plus M2 G sine theta. This is the friction in the case of P. So if I see the option, so in this option P equals to this theta is 5, then I am getting answer m1 plus m2 g sin theta. This is the friction values acting on this m1 plus m2 g sin theta. So this is the answer. So this is P and this is 2. P and 2, this is not correct. P and 2, we have 3 options, so you have to solve for another Q. Now if I see Q option number Q will check. It says theta equals to 10 degree. You take theta as 10 degree. So this is inclined plane. I have taken theta as 10 degree. There's a block over here, another block is there. This M2 is important because here the external driving force is M1 plus M2 G sin theta. And if I've already seen that if theta is 10 degree, the 10 degree is less than 11.5 degree, implies no slipping. If there is no slipping, then the friction that is acting on this block the friction that is acting on this block must be equal to this. Because it is not slipping, the forces in that direction must balance. So therefore the friction that will act equals to m1 plus m2 g sin theta. It is the same frictional force that will act. So Q option, if I see the Q option at this, it also should be option number 2. And Q is also 2, Q is 1, it is not possible. Q is 2, Q is 2, Q is 2. All three are again correct answers. So to see for the third one, that is R. You have to see R. C will take R equals 15 degree and see what is the answer. Now option number R will check. Inclined plane, theta 15 degree, block is there, second block, subjected to external force of m1 plus m2 g sin theta. What is the friction that will act on this? That is the question. But now in this case, the situation is that at theta equals to 15 degree, which is greater than 11.5 degree. If theta exceeds this value, then it will slip. So in this case, the block M2 slips. If this block M2 slips, this M1 also will slip, because M1, the movement of M1 is prevented by this block, because this M1 is not having any friction. So if this slide, that also will slide. So the block M2 slips. If it slips, then in slipping condition, then the friction that will act is dynamic friction. That is your linear question. The dynamic friction is same as the kinetic static friction, which is 0.3. So here that will act as a limiting value. It will act as a limiting friction will act, because this is sliding. So in case of sliding, the friction and the friction is limiting. Friction is limiting. So what is the limiting friction? The limiting friction will be mu s into n. N is n2. Mu s is 0.3. n2 we have calculated, that is m2g cos of theta. This is the situation. If I don't put the value, then it is mu s m2 g cos of theta, that is Fl. So the limiting value we are getting is this. So therefore the friction will act is this. Because this is slipping, so in case the block is slipping, the friction that will act is obviously equal to this. So for option number R, friction is mu m2g cos theta, so 3 is correct. Mu m2g cos theta, so 3 is correct. So 3 is this one, R 15 3, R is 3, R is 3 is there here, so this is correct. Then no one is having R3, so therefore this should be the correct answer without solving for S3. But let us solve for S3 as well. At theta equals to 20 degree, and you can see that if I have the situation and I take theta is 20 degree, then this is for option number S. Theta is 20 degree, which is greater than 11.5 degree. So again the block which is there is subjected to external force of m1 plus m2 g sin theta, but because theta is more, this will slide. If it will slide, then the friction will act along this, and that will be because it is moving in this direction, there is net acceleration existing, so friction will be limiting in nature. That is the limiting friction we have got as this. Again in this case the limiting friction that will act is mu m2g cos of theta. Mu s or mu only, right? No problem with that. So this is the friction that will act. If this is the friction that will act, then for S as well, this is also the answer. So S is 3, S is 3 is this one, so this is the correct answer. So therefore option number 4 is the correct option for this question. Okay, thank you.